Hello, how are you all? I hope you all are fine and doing well. My name is Sayyida Fatma Rizvi, and I bring for you people a very interesting and informative videos of physics. How are you all, guys? I hope that you all are fine and doing good. So today my topic is about electrostatics subtopic, which is about Coulomb's law. Now, Coulomb was the scientist who discovered the law about the charges that he discovered that the force of attraction and repulsion exists between the 2 point charges. So, in order to study about the force of attraction and repulsion between the charges, he discovered a law and named that law as Coulomb's law. So, before starting the topic, please like, share, and subscribe to my channel, Physics Encyclopedia, in order to get the interesting videos of physics. So, let's start about the Coulomb's law. We know that a force of attraction and repulsion act between the two charged bodies. How is this force affected when the quantity of charge on the two bodies or the distance between them is charged? Okay, we already know that the force of attraction and repulsion exists between the two charged bodies, and how these forces are affected if the two bodies or the distance between the two charged bodies is charged. In order to answer these questions, a French scientist, Charles Coulomb, in 1785 experimentally established the fundamental law. Okay, the French scientist Charles Coulomb in 1785 experimentally established the fundamental law of electric force between the two stationary charged particles, or we can say the static charged particles. He discovered the electric force between the two static charged particles. So, what was that famous Coulomb law? Alright, that most precious Coulomb law. Okay, that Coulomb's law was the force of attraction or repulsion between two charged bodies is directly proportional to the product of magnitude of the bodies of the charged bodies, and inversely proportional to the square of distance between them. Okay, so the force of attraction and repulsion between the charged bodies is directly proportional to the magnitude of the charged bodies. Okay, and inversely proportional to the square of the distance between them, as the law has two parts, that the force of attraction and repulsion is directly proportional to the product of magnitude of bodies and inversely proportional to the square of the distance between them. So, in order to illustrate the Coulomb's law, let us suppose if the charge Q1 is of 20 microcoulomb and the charge Q2 is of 10 microcoulomb. So, in this case, two situations exist. Okay, we suppose that Q1 is equal to 20 microcoulomb and Q2 is equal to 10 microcoulomb. In this case, two situations exist. If the two charges Q1 and Q2 are the like charges, so the like charges will repel each other. And if the two charges like Q1 and Q2 are unlike charges, so unlike charges will attract each other. Now, in this case, the charges are opposite. If the charges are opposite, then 20 microcoulomb charge Q1 will attract the charge 10 microcoulomb Q2 more. Okay, because the charge Q1 is of 20 microcoulomb, so it will attract the charge Q2, which is of 10 microcoulomb. Now, the question arises that the two opposite charge will attract each other. Two opposite charge mean positive and negative will attract each other. We suppose that charge Q1, which is of 20 microcoulomb, is the positive charge, and Q2, which is of 10 microcoulomb, is the negative charge. So the positive charge will attract the negative charge more because it is of 20 microcoulomb, and 10 microcoulomb charge Q2 will put less force of attraction on the charge Q1. So 10 microcoulomb, obviously 10 is less than 20 microcoulomb. So negative charge, which is q2, which is of 10 microcoulomb, will put less force of attraction on the charge q1 as compared to the charge q1. Charge q1 will put more force of attraction on the charge q2 because it is of 20 microcoulomb. Why? Again I repeat, why? Because q1 is of 20 microcoulomb and q2 is of 10 microcoulomb. If in case the charges are similar, so force of repulsion by the charge q1 will be more as compared to charge q2. So if the charges are similar or the like charges, like positive positive or negative negative, so in this case the force of repulsion by the charge q1 will be more as compared to charge q2. Let's suppose that the charge q1 is negative and the charge q2 is negative, but charge q1 is of 20 microcoulomb and charge q2 is of 10 microcoulomb. So the charge q1 will exert the large force of repulsion on the charge q2. Okay, so the force of repulsion by the charge q1 will be more as compared to the charge q2, and q2 will exert less force of repulsion on the charge q1. If the distance between the 2 point charges are greater, then the force of attraction and repulsion between the point charges would be less. Okay, if the distance between the point charges are greater, we have heard in the Coulomb's statement, second law, Coulomb's law, that the force of attraction and repulsion is inversely proportional to the square of the distance between the point charges. So if the distance between the 2 point charges are greater, it means that the force of repulsion and attraction between the point charges would be less. If the distance between the 2 point charges are lesser, then the force of attraction and repulsion between the charges would be greater. It is obvious that if the charges are closer to each other and the distance between the charges are less, so it means that the force of attraction and repulsion between the charges would be greater. And if the distance between the point charges are greater, it means that the force of attraction and repulsion would be lesser. So here we have taken the diagram. We have taken 2 point charges q1 and q2, and the distance between them is represented by r. So Fe, which is Coulomb's force, is equal to k q1 q2 divided by r square. So according to the statement of Coulomb law, we have given it the expression which is F is equal to k q1 q2 divided by r square. Now what is k? K is the constant of proportionality. We know that F is proportional to q1 q2, the magnitude of the charges, and F is inversely proportional to the square of the distance between the charges. So according to that expression, we have given that Coulomb's law mathematical form, which is F is equal to k q1 q2 divided by r square. So here you can see the diagram, q1 and q2, and the distance between them is given by r. So in the second diagram, you people see that q1 and q2 in the first, as you can see in the first phase of the diagram, q1 and q2 are similar charges, so they both will repel each other. In the second phase of the diagram, you can see that q1 and q1 is positive and q2 is negative. So both charges will attract each other. So let's come to the next diagram. In the next diagram, you can see that the first charge is negative and the other charge is positive. q1 is negative and q2 is positive. So both the charges will attract each other. Okay. In the second phase of the diagram, you can see that both the charges q1 and q2 are negative, so they will repel each other. So Coulomb's law, we are talking about the point charges. So there lies a condition that the size of the point charges must be smaller than the distance between the point charges. It means that if the distance is larger between the point charges, so according to the distance the point charges size must be smaller. Okay, if the distance between the point charges are greater, if the distance between 2 point charges are greater, it means that the size of the point charges must be smaller than the distance between 2 point charges. That is the condition, and that is the must condition in the Coulomb's law. If this, let's suppose if the size of the point charges is of 4 meter and the distance between 2 point charges are also 4 meter, then no force of attraction and repulsion will act on these point charges. Let's suppose that the size of the point charge is of 4 meter and the distance between the 2 point charges is of 4 meters, then no force of attraction or repulsion exists. Why? Because we have read that if the distance between the point charges are greater, then the size must be lesser than the distance between the point charges. So let's study about the expression of the Coulomb law. F is directly proportional to Q1 and Q2. Okay, F is directly proportional to the magnitude of the charges Q1 and Q2, and F is inversely proportional to 1 divided by R square. So we write the expression as F is directly proportional to Q1 Q2 divided by R square, where F is equal to K Q1 Q2 divided by R square, and K is a constant of proportionality. Where let's suppose if the charges we have different values of K. If the charges are placed at the space, it will have different value of constant, and if the charges are placed in air, so it will have different value. So if the charges are placed in air, so the constant of proportionality is equal to 9 into 10 raised by 9 Newton meter square Coulomb minus 2. Okay, so let's suppose let us find the value of the K. We have written the value of K. Let us find out the units of the K. So in order to find out the unit of the K, we multiply F multiplied by R square divided by Q1 Q2. Okay, so K is equal to, F unit is Newton, and distance unit is obviously meter. Here we have R square, so we can write Newton meter square, and here we have two charges Q1 and Q2, we can write as Coulomb square. So we get K is equal to Newton meter square divided by Coulomb square. So the final expression of the constant of proportionality unit which we get is K is equal to Newton meter square Coulomb minus 2. So that's all about the Coulomb's law, in which we have studied minor information and the explanation and the definition and the mathematical expression derivations of the Coulomb law. I hope that you people enjoy the video. Keep liking, sharing, and subscribe to my channel, and do spread my videos worldwide. It's my motive to spread physics video worldwide, so that people get advantage of these videos. Thank you so much, and stay tuned towards my channel. Allah Hafiz.